This lab is all about constant velocity. In the next few minutes, I will show how I observed a basketball rolling on a sidewalk and was able to determine how the position changed over a period of time. I was also able to determine how the position was expected to change in a perfect world, and I compared these two sets of data. Here you will see a series of equations that helped me along the way. We focused on the concepts of Newton's second law and the momentum principle. Now onto the observed data. Using a video I filmed of a rolling basketball, I used Tracker and Excel to compile data reflecting the ball's observed motion. You can see the ball's center of mass denoted by the small red circle in the center of the basketball. You can also see the data collected from this video on the right. For the predicted motion, we used a coding simulation. Here you will see some clips showing what I changed from the starter code. On line 28, I set my variable for the mass of the ball equal to 0.624 kilograms. This is just the standard mass of a basketball, as you can see in the comment on line 29. On line 32, I set my initial position vector. On line 33, I set my initial velocity vector. I calculated both of those values using the equations previously in the slides. On line 44, I inserted the value of 1.167 seconds into my while loop because when I was choosing my frames on Tracker, that was the last recorded time. On line 49, I set my net force vector to 0 because in this lab we are observing an object moving at constant velocity. And according to Newton's second law, if the object is at constant velocity, there should be no net force acting on said object. At lines 54 and 56, I rewrote the equations to reflect the ones I showed earlier in this video. After running my code, this is what happened. As we can see, it looks very similar to my Tracker simulation. Finally, I compared my model to my observations by plotting my data on the same graph in Excel. The two lines look very similar. This proves that my object was in fact traveling at constant velocity, with slight variation due to a few sources of error. Here, the red line represents my basketball's predicted motion, and the blue line represents my basketball's observed motion. This slide will list a few of the main sources of error for my observational experiment. Now let's answer a few questions. The first question is written on this slide. If I had flipped the axes on Tracker, not much would have really changed. The actual physical motion of the object would have remained the same, but my analysis of the data would have simply looked different. My graph would have looked more like an upward slope. Here you'll see the second question. A real-life ball rolling on the ground is very different than a perfect simulation. In the case we observed, we know that the forces of gravity and a normal force cancel each other out. However, there are so many other forces acting on the ball, it would be impossible to count them all. Aside from some of the forces that could be a result from error, every single object on Earth exerts a force on every other object. That means that there are thousands of forces acting on my ball. However, most of them are pretty small, which makes them almost insignificant. Also, because the ball is being pulled at from every direction in every direction, they all cancel out pretty easily and we can really ignore them. The only forces we really focus on are the most significant and strongest ones. In conclusion, most of my predictions were correct. My ball was in fact traveling at a constant velocity in the negative x direction, and it was pretty similar to the predicted motion simulated in the coded version of this experiment. Thanks for watching, and I hope you learned a little bit something about objects moving at constant velocity.